Good evening, everybody, and welcome to another episode of vBrownBag. Tonight, we're actually kicking off the Homelab series. We're going to be talking Hyperconverged Homelab 2.0 with Josh Stenhouse at Joshua Stenhouse in Twitter. As always, if you want to join us on the conversation, we will be monitoring the hashtag vBrownBag, both live today and in subsequent days if you want to reach out back to Josh or any of us. And we have several channels. At vBrownBag is the US channel, it's the main one. But we also have in Latin America, EMEA, Brazil, and those take place in other days. We're very happy with Brazil, who is a new channel, and they basically have been doing a great job. So shout out to Valdez here. Tonight you're being hosted by Ariel, that's myself, at Ariel Sanchez Moore, and I'll let you introduce yourself, Anthony.
I am Anthony. You left the R in there. Hook, co-hosting. So I'll be watching Twitter and the questions. So bug us, and we will interrupt at very inopportune times and try to get your questions answered.
And our guest, as I said, is Josh Stenhouse. Josh, we'll let you introduce yourself while we're making you the presenter.
Sure, yeah. So let me share my screen because, of course, I do have a slide with a cheesy picture. 1 second. Okay, and let me just expand my audience view so I can see the refresh rate. Perfect. Okay, so thank you very much for having me, guys. It's a pleasure to be on this. I've watched many myself, both online and also in person at multiple VMworlds. Based in Boston, Massachusetts, in the US, despite my accent, originally from Yorkshire, England. I'm massively into PowerShell, self-confessed PowerShell geek. I have a blog at virtuallysober.com, which I'm going to touch on a few times. I spent 8 years as an end user, started as a MCSE Windows 2000 on a help desk role, progressed through that, mostly through taking on this exciting new technology of virtualization, which is why we're all in this session today, and then ended up through various different quirks of life working for Zerto, because I actually ended up buying it as an end user, and they came along and said, hey, we're interested in hiring a sales engineer in Europe. And I'll be honest, I didn't know what a sales engineer was, but I thought, well, why not? What's there to lose? So I spent 4.5 years at Zerto. Never left my end user cap off. That is something I definitely pride myself on, that I'm a user first, and then whatever company I'm working for comes second. And so I was an SE at Zerto, then I progressed on to technical marketing as an evangelist, and then today I'm actually a sales engineer again at Rubrik. But one thing I can promise you is that there's going to be no vendor pitches in this session, because I'm going to talk about labs and my dirty obsession with spending probably too much money on labs, but also some of the reasons behind it and my findings along the way. So if you haven't come across it before, you might have heard about it. This is the picture that you might have already seen, that a few years ago I built the Hyperconverged Homelab, and it was a mishmash of a couple of motherboards from various different sources. So I had some NUCs in there, some ASRock CPU, well, Intel CPU integrated motherboards, 32 gig of RAM each, and then in this case I also rammed in a Synology NAS, and then I had a couple of spinning disks and a couple of SSDs, and then an integrated switch, and it was basically all crammed inside the case, and it worked, but it was also quite limited in its capacity. And it's been probably one of the most popular blog posts on my website. So if you want to learn more about this, just Google Virtually Sober Hyperconverged Homelab, and you can see how I put it together and all the different components. But what I'm really excited to talk about in this session is actually my new Hyperconverged Homelab version 2.0. But with the existing investment in this kit, I'm sure you agree, I can't just throw it away and say, oh, I'm creating a new one. You've got to do something with your existing investment. So the first thing I did is I emptied the case. And if you haven't heard this story before, that for my 30th birthday, I went to Japan. Lifelong dream to go to Japan. I'd never been before. And I was walking through Akihabara, the tech district of Tokyo. And I'm walking along the street, there's computer stuff everywhere, geek stream. And across the other side of the street, I see a computer case. And I I just, I have a Wayne's World moment. I see it and I think, oh yes, you will be mine. And I can see it across the road. I cross over, I look at it, I managed to decipher it's a in-win D-frame mini. So these cases, unfortunately, you can't buy them anymore. I did see one go secondhand for $300, which is a bargain, but the new version of these aren't mini, they're full ATX cases, and they're about $800. I got it for about $300 at the time. But I absolutely love this case. If I'm going to build a new lab, it's going to be in my favorite case. I'm not going to use something else. So what did I do with the existing components? So I've got to put them in something. So I settled on a Lianli T60B test bench. So now I'm calling this the Hyperconverged Homelab 1.0 in preparation for the second one. And this is kind of cool because I didn't just take the two motherboards, the two ASRock motherboards and the two Intel NUCs existing and the Synology NAS. I also had some other NUCs lying around, and they all had their own power supplies, their own cases, and the power supplies themselves took up a huge amount of space. And if you look at the running wattage requirements of the first generation Intel NUCs, it's tiny. Having a whole power supply brick for each one of these NUCs is such a waste of space. So what I did is I took 9 Intel NUCs and I put them in the T60B test bench. And you can get a little adapter for each of them. So you're just converting the power supply into a 4-pin Molex. So 9 motherboards in one case running on one single 500-watt power supply unit. And then if we scroll it out here, you can see, so the two ASRock motherboards, I wanted to also switch my lab to 10 gig Ethernet, and these two motherboards have a PCI slot, so PCIX, sorry, so I actually bought some 10 gig cards to put in those. But interestingly, you can see that the motherboards are stacked on top of each other. So how do you put a 10 gig card inside a motherboard when it's got another motherboard on top? Well, very simple. You can see here, this is actually a PCI Express extension cord, and I basically just strapped the two cards together, one upside down, and then ran the cable between. So there you go. I managed to get those upgraded to 10 gig, but the rest of the lab is on 1 gig. So I also ripped the back off a 1U 24-port 1 gig switch. I have that strapped to the back with some just neat cabling across, so 1 gig end to end. Also powered off a little adapter that you can see here. And here you can see the front view where I also ripped the case off my Synology for the shared storage over iSCSI, also a bit of NFS for some shared files across the network. And that's how you have a NAS, shared iSCSI storage, 9 ESXi hosts, one 500-watt PSU, and one power plug for the whole thing. So if you look at the vCenter on the back end, it's around 63 gigahertz of CPU capacity, 175 gig of RAM, and it says 24 terabytes of storage, but that's a lot of distributed storage in the hosts themselves. In terms of the shared storage, it's around 2.7 terabytes. And for me, this is what I'm actually now using as a DR site target. Because I have a lot of compute available, one of the things that I spend a lot of time is writing PowerShell scripts on automating disaster recovery. So a la SRM, but plugged into whatever you want. And this for me now serves as a DR target, because the one thing you need is a lot of CPU when you're doing a boot storm and bringing everything online.
Just to stop you right there, we're getting a lot of comments of, oh my God, what? That's amazing. And because I have NUCs and I know that they're excellent because they're low power, most of them have a very unnoticeable fan. And one thing that I was drawn to in your spec list was 500 watts. That's amazing for 9 hosts. That's pretty cool.
Yeah, and because each of them is consuming so little that, unfortunately, I can't plug into the PSU and see what the current load is, but I can tell you by the stability of the environment that it's rock solid, and I've never had a single outage on it.
Very
cool.
So
speaking of rock solid, I have to ask about your case. Has that been like drop tested or any sort of thing? Because that is a pretty serious case.
Well, I don't know. I'll be honest. I wouldn't dream of ever dropping it. I'd probably scream in horror if something happened to it. So, it's all I can say is it's my dream case, and as long as a motherboard fits in it in the current form factors, I'm going to keep it.
Very sweet. Akihabara, nonetheless. Yeah, where dreams are made of.
Yeah, there's also a lot of weird stuff there. Don't get me wrong, but I I definitely like the technology. So what next? I've got my favorite case in all this world, and it's sat there looking rather empty and lonely. So we're going to put something really cool in it. And, now as you get older, you get a little bit more budget, you can start to splash out a bit more. And I don't have many expensive hobbies. I don't collect cars or build them. I don't have any motorbikes. In fact, I don't even have a bicycle in this country, and I did when I lived back in England. So if you're going to have a hobby, then this is what I picked. So I'm going to spend some money on my lab instead. And also I'll say that I use this every day for my job. My day job, I'm a sales engineer. I need to demo things, and the more scale I have in that demo, then the more believable it is for people looking at what I might be pushing, in this case, rubric. So scale is important. And I need to run a decent amount of VMs. So what did I build to put in this new lab? So spent a lot of time on this, a lot of umming and ahhing, I'd say, 15, 20 different revisions of different motherboards, RAM, disk combinations. Originally, I was looking at maybe a flash tier and then spinning disk, and some people gave me some crap on Twitter and said, why are you putting spinning Rust in a new lab in 2017 when I first started specking this out? And I had to agree with that and think, yeah, we can't be backwards here. We need to be all flash, need to leverage some dedupe in here and go down the HCI route, because for me, HCI is the future. And so my new lab should reflect that future. So first of all, I opted for 3 Supermicro X10 SDV 8C TLN4F Plus motherboards. So each of these has an Xeon D15141, and each of those consumes around 45 watts, which is very important when we come on to how we're going to power these. They both have 10 gig, dual 10 gig SFP plus transceivers, which is very important because I need 10 gig end-to-end connectivity, 1 for HCI and 2 to then plug it into my rubric appliance to have backups running at full speed. I don't want to slow those backups down by going at 1 gig in the slow lane. But then the next thing I need is memory, because I don't just want to run one hypervisor, I've got to run multiple, because I've got to be able to showcase and protecting VMs across multiple hypervisors, but also for my own learning. If I'm not touching different hypervisors and seeing the differences, then I'm limiting my own abilities and also limiting my status as a trusted advisor. When I go and speak to a customer who's using X, I can also know Y and Z. So very important that I can run nested. And of course, if you're going to run nested, you need memory. So I threw budget to the wind and I said, right, I'm going to do 128 gig of RAM per host, because usually when I look at a cluster, it's usually memory bound before I see it hit the CPU and the disk, especially when you're looking at SSDs. So I wanted to make sure that I wasn't going to hit that memory limit. Next, if you're going to use a flash cache tier in 2017, 2018, it's got to be NVMe. So really it just came down to what size and also what model. So I went for the 960 Pro, and I went for 25% of my capacity tier. So I went for 512 gig, and the Pro because it had the better capability to sustain writes over a longer period. I forgot the actual figure. I think it was about 2.5 million, 3 million something. But I just thought, if that's where all the writes are going to be hitting, then it's worth the extra money to make sure that it's not going to conk out after 12 months of me using it for some hypervisor action. And then for a capacity tier, crucial 2 terabyte SSDs. And of course, for all of these 3 sets, because I got 3 motherboards that I'm going to put in this one case. Pretty exciting. So I mentioned networking. You can't do HCI and not have 10 gig. It's like, I don't know, cue some analogy of a Ferrari and putting in, I don't know, two-stroke engine fuel. It's not going to work. So for 10 gig networking, I used a Ubiquiti Edge switch 16 XG. So that gives you 12 SFP plus, 14, 10 G base T, 160 gigabits a second non-blocking throughput. And out of the box, it comes 1U. It's pretty heavy, and it's got these little screaming fans at the bottom, which aren't going to cut the mustard in my home lab. So this is not going in a rack for me. So first of all, I rip off the case. I install two 120 mil Cougar fans, only 16.6 dBA. I'm just literally screwing them in the heatsink because there's no other way. But I'm not planning on taking this back, so I'm fine putting a screw in there. And this is actually a picture of me using it at a customer site where they had a problem with the 10 gig networking, and I had to prove that it was an issue with their network. So I just rock up with my switch, and it's got two garden hooks on there, one for hooking it onto my case, but as you can see in the picture, it also handily hooks onto the front of a rack as well. Of course, you got to be careful. You don't want to touch the transformer here. I actually brushed by it the other week and got a nasty little buzz. But hey, if you've got an open air case, then why not have an open air switch as well? So I'd much rather have this than the weight and the screaming of the fans. And actually, you can see one of the fans here isn't even spinning because in this data center at the front, it was so cold, it's just stopped spinning altogether automatically. But in my lab today, both of these are spinning.
So on that slide, we got two questions. One is, what SFP Plus modules are you using for that?
Good question. So I'm going to come on to cabling, but I can tell you definitely no transceivers. I'm just using twin axe cables because I'm trying to keep the cost down where I can. And for me, there's no point going transceivers and fiber. It's much cheaper and cost effective to just do twin axe.
Makes sense. My other question was actually, before you answered it, was going to be about that open the MOSFET there to see if you've ever gotten bit with it. And you've already answered that.
Yeah, it hurt. But you know what? Like I said, there's so many things in an open air case that you don't want to touch anyway. I just thought, well, I might as well add to the list.
So we got a question here asking about the SFP modules because I believe that 10 gig switch is known to only work with certain modules.
So I've only ever used it with the twin axe, and I have never had an issue. And
you got this through the same website?
No, the twin axe are just cheapo 10G tech from eBay. They're like $30 each max.
Right. Okay. No, it's just, you can buy twin axe from lots of different vendors. So yes, thank you.
And the interesting thing I've found with the 10G tech is that they have 20 different versions of the same cable, and it just says each different switch vendor. And I've tried them all, and they all work irrespective. So I think they just changed the label, and there's no actual difference. But that's just my theory.
No, there was I can't remember what the site was called, FS something out of China. They would ask you, which vendor do you want us to emulate? And they would basically burn that vendor in.
So on that subject, good segue, cabling and PSU. So what do I have powering this? It's actually a Seasonic Platinum 400 watt fanless power supply. So only 400 watts is going to power a 3-node cluster. Pretty impressive, but not that impressive when you think about each motherboard only consuming 45 watt. It's actually quite a lot of headroom in there when you're picking power efficient motherboards. And then, of course, the power supply itself has only got one motherboard cable. How do you split that 3 ways? Very simple. Fantastic website. I think it's somewhere in maybe South Korea or Taiwan it's actually based, so you do have to wait quite a decent time for shipping. But if you've never been to moddiy.com, little plug here, I definitely recommend it. They've got every connector under the sun, and if actually you can even order some cables that they'll make up for you, and they ask what you actually need. But I bought 2 Y splitters for the motherboard power to take the one from the motherboard and just loop the cabling round, tie it in, try and make it look neat. So coming out the front end is just 3 motherboard connectors to power my motherboards that you can see here. So started off by installing the 2 terabyte SSD. So 1, 2, 3. We can see the cables are routed around the back and coming out the left-hand side, ready to plug into the motherboards. And then I got my 3 motherboard power cables waiting for the motherboards to go in. So we put in number 1, cable it up. And what I'm actually doing to stack the motherboards is pretty simple, is just using multiple mounts. So just keep screwing them into each other, and you're just building up and stacking them on top of each other. It's nothing more complex than that, and just making sure you've got enough gap in between them that the components aren't touching, which is obviously going to be bad for a short circuit, but also enough room for them to breathe and get the air coming out from the bottom. So a bit of a juggling act there, but also I'll show you in another slide, when you look at how the cables touch at the top as well, it gets a little tricky. So then you put on motherboard 2. Look, you can now see clearly how I'm just stacking them on top of each other. And connected the second one, we can see the RAM, everything's going in nicely. At this point in my build, you've got to stop for a beer. The blog's not called Virtually Sober for no reason. If you're going to be working on this, it'd be rude not to have a beer, and this is my favorite English ale that managed to pick up at a local import store. So this is reasonably expensive in comparison to what you get at home, but when in Rome, why not? Then we're going to put in motherboard 3, and for the third one, I just used some cool little red thumb screws to just do the final one, because I figure, hey, I'm probably going to be taking these on and off a reasonable amount throughout the course of the life of this lab. And also it looks cool. So that's how you put 3 motherboards in one case. Pretty cool.
Yep. The only question we had so far is where or how are you handling the power up and power down?
Good question. So I've only got the front case, the front power switch connected to the very back motherboard. And I can answer that on this very slide with the network cabling, because I've got dual 10 gig for each of these motherboards. And you can see here now the 10 gig switch hanging off the back. So if I'm here, I'm going to work from right to left and I'll answer this question as I go on. So 6 10 gig connections using these 10 GT Tech twin axe cables, 0.5 meters. They route nicely around the side here. Then I've got 2 cables here coming off down to the bottom. These are then going to the Hyperconverged Homelab 1.0, the ASRock hosts. And then I've got 4 twin axe here, which are actually going down to my Rubric appliance here. So this is the 2U Rubric rack mount appliance that I use for demoing. And then as we get to the 10G base T, these auto negotiate up or down. So I'm actually cheating and just using these as 1 gig ports. So the first 3, as you can see here, here, and here, are connected to IPMI. So I boot the server, I press the power switch, and it turns on ESXi host 1, the back motherboard, which has the switch. The other 2 have power, but they haven't been switched. Very simply, I just log into IPMI, which is online and available as soon as they have power, and I just click start host. And there you go. And I'll be honest, it's not something I do every day, and for the times I have to move it or perform some maintenance, logging into out-of-band IPMI is easier for me than trying to cable some ugly mess. And then the very final cable, this red one coming on the bottom, this is actually just connecting this switch over 1 gig to the 24-port switch on the Hyperconverged Lab Home Point 1 and the remaining 7 ESXi hosts, and then an uplink to my internet connection, yada, yada. So all was not rosy. I can't pretend that this initial config worked perfectly. So I want to take you through my 2 issues that I had, because I don't want to pretend that everything was perfect when it wasn't. And the first issue I had was CPU utilization. So I had an idea in my head. I'll be very honest with you that I thought to myself, I'm going to go hyperconverged. And if you look at the players out there in hyperconverged, I want to go with a platform that's REST API driven end to end. I don't want APIs that are just a bolt on, and I'm going to go Nutanix and AHV. And I was ready to divorce VMware from my lab and maybe just run an ESXi host nested. So that was the intent. And so I started, I went with Acropolis Community Edition. I put it on the 3 hosts. I built a cluster, and it was simple to set up. That there's no doubt. Extremely simple to have my 3-node cluster up and running with all the built-in functionality of VROPs, of replication, of a vCenter all baked in. But it comes at a cost. And the first cost is CPU. So I found that my 3-node cluster on AHV doing absolutely nothing, no VMs powered on whatsoever, was eating up just shy of 15% of my CPU capacity doing absolutely nothing. And this actually then meant that I couldn't power on more than 50 VMs in the cluster. And the key reason was that there's no ability to remove, or from what I could see, the HA limits. It's automatically reserving the capacity on the additional hosts, and that's fine for production. But for my lab, I don't really care if a host dies. I'm more concerned about the host dying than I am the VMs on it. I could just rebuild them. I'd just be crying about the host. So I don't care about HA. I don't care about reservations. I need the maximum number of VMs on the investment that I've leveraged. And just one really annoying thing is no multi-VM select box. I can't get over how I can spin up 100 clones of VMs. I can only power on a subset because I can't utilize the full cluster capacity. And then I don't even have a checkbox to select multiple VMs. I've got to do it one by one. So the net result of me trying AHV is, one, I liked a lot of it, but it wasn't efficient enough for my lab. Otherwise, if I spend that much money and invest that much time and I only get 50 VMs, I'll be honest, I felt like I just wasted my everything that I had. So it left me with pretty much no choice to go back to beloved VMware and vSphere 6.5. And okay, the REST APIs aren't as expansive. They're only just being introduced. And yes, it is more complex to set up to get to the same level of functionality of all the additional components. But if you're just going to do ESXi and a vCenter, then we all agree that's not complex. But here's the key difference. With no VMs running, I'm using less than 1% of this CPU, 0.3% to be exact. And for a home lab especially, where, yes, I've got 8 cores, but it's not a 2U rack mount server with dual 16, 32 cores or something huge. It's only 8 cores and 1 CPU per host. So I've got to go with whatever gives me the lowest utilization and the most efficiency. And the net result is I could power on more than double what I could in the AHV cluster, so 115 VMs, plus nested Acropolis and nested Hyper-V. So in terms of the value back on my investment, it was absolutely no-brainer. As soon as I switched back to ESXi, I basically said, I'm sorry, VMware, for ever doubting your efficiency. I love you, and please make everything okay. And it did. And I also got my multi-VM select checkbox back, which, I've never missed such a simple thing so bad. And I can also remove the HA limits and just go full pelt on this cluster and not care if one of the hosts fails. Second issue. Go on, sorry, we have a question?
No, I work for VMware, so just keep on saying everything you've been saying.
Hey, you know what? I will say, I'll be very honest. If CPU was not a problem and I could buy a big fat dual CPU motherboard and it was net new, I might be more inclined to go down HV, but I also had big trust issues. There's something about being able to just log into an ESXi host, and it doesn't matter what's happening with the cluster, with the vCenter, I can log into that host, and as long as it can access its storage, the VM's still running. That is a huge comfort factor. Switching to HV, you've got to let go of that. I personally don't know if I had my own infrastructure, whether I'd be able to cope with that for tier 1. I'll let other people make their own decision, but that's the only other thing I'd add. But hey, for my lab, 8 cores per host, there was no way I could do HV and then nest something else. It was the other way around. So second issue is cooling. You can see here, I've got passive heat sinks on each motherboard, and I've got 220 mil fans at the bottom that are going to cool it. And what I can tell you is that under limited load, if I'm doing 10, 15 VMs per host, everything's running fine. it's great. But as soon as I started stretching this, once I'd put it on ESXi and I was pushing 30 plus sometimes 40 VMs per host, that's where it started to turn into a cooker. So the last, I did see it at one point hit around 95 degrees Celsius, which is around 200 Fahrenheit, before the front host, believe it or not, is actually the first one to conk out. Not totally sure. Based on my basic physics, I would have thought it had been the back one the most constrained, but the front one, as it seems, wasn't getting the same air ratio as the back two. So it was actually the front host that conked out first when I put it under load. So 95 Celsius is not good, and it's certainly not good for the longevity of the lab. So I had to fix it. So the fix was twofold. First of all, I installed a 140 mil fan closer to the hosts and a bit further to the left, covering the heat sinks. And that certainly made an impact, but alone it wasn't enough. So I also had to install these little 4 centimeter fans on each of the motherboards, and only together could I bring it down to 61 Celsius. Separately, it was still getting, mid 70s or late 70s under load Celsius, which I wasn't happy with. So I definitely needed to maintain that. And okay, it's not quite as clean a look, but actually I think it's a bit more interesting. And I couldn't just do one fan on the top motherboard. I also had to do it on the other two. So here you can see a down shot and just a little heat sink and the little 4 centimeter fan. And as per usual, I just screwed it straight into the heat sink because there's no way to mount it. It's not supposed to have a mount. But there we go, we'll just screw it in, and that did the trick. And here you can see the net result on the IPMI. Decent a number of VMs at around 61 degrees Celsius.
That is pretty cool. And I bet you kind of miss the NUCs at that point, because those things, they're never going to require this much cooling. And I saw that your power supply was fanless, so it must have torn at you knowing that you're going to have to add fans to this.
It did, but you know what? They're still very quiet. The lab as it is now, you could put it right next to you and you can work, and it's not going to annoy you. Although it is on top of a 2U Supermicro server, which is running Rubrik, which is like a jet engine. So that's why it's in the basement right now, and all the effort that I put into making sure my lab is silent is kind of nullified by the 2U appliance below it. But that might not live there forever. We don't know. So I'm just making sure that that's covered if it comes to it.
Yeah. No, and you'll probably take it traveling at some point with you, and that's when all of this will pay off.
Yeah, I agree. So that's the end result, is what you can see here with the glass side of the case on, and it's my new little baby. I love it to bits. And what I also want to say is that even though it is quite a lot of power and equipment and it's extremely efficient, I don't just leave it there and look at it. I most certainly use it. So what do I use it for? Well, here you can see my vSAN. At the minute, I've got 115 VMs powered on. I definitely think it's got capacity for more, but one thing I haven't done is spun up any VMs in my 2 nested hypervisors. So I'm going to leave it at 115. I need to put 5 VMs in Hyper-V, 5 VMs in Acropolis. I'll see where it levels out. And then you can see the storage available is pretty high as well. So I'll be honest, one thing I was really disappointed with in vSAN is that you have the ability to configure iSCSI targets in 6.5, but then this VMware stopped short of allowing you to use that to create a VMFS data store, which would have been amazing, because then I could have shared my vSAN storage out to my Hyperconverged Homelab 1.0, which would have been amazing. So in the meantime, I actually started this the other night. I just downloaded an OpenFiler, put it in a VM, put it on the vSAN, and I'm just going to use that to share out an iSCSI target to the first home lab. So I've got some additional storage capacity in there, and I'm leveraging some of this 4 odd terabytes that I have available.
One other thing you can do if you want to play with other iSCSI initiators, there's an EMC. I can't remember the name of it, but it's basically like a virtual EMC that you run in a VM, and it gives you a little more options than just OpenFiler or FreeNAS. So I invite you to try that one too.
You know
There we
what?
go. Yeah, Unity VSA.
I've spent so long competing against EMC in various different roles. I don't think I could bring myself to touch it. I'm sorry.
Oh, good point. Good point.
But hey, I like your suggestion. Maybe someone else could. I don't know. So what I want to do at this point is give you a quick demo, and a demo of something that I run against the lab, and give you an idea, other than my day job, what else I use this sort of capacity for with this many VMs. So let me switch across to my screen. So here you can see I've got my vCenter, I've got 2 data centers, Hyperconverged Homelab 1 and 2, and then here you can see I've got my vSAN. So one cool thing that I wrote last year and back in July, and it's definitely been one of the more popular blogs that I put out there, was how to create a vSphere change management database for free. And the reason I created this was twofold. One, I was doing a series on how you interact with SQL databases using PowerShell, and I wanted to give an example that was pertinent to my background and my primary audience, which was virtualization. And two, when I sat and thought about what could I actually do if I've got a SQL database, PowerShell, PowerCLI, and a vCenter, I came to the conclusion of change management, because if you think about a VM in a vCenter, if you edit that config, then you've got no way of logging the previous config. Once it's changed, it's changed. Yes, you can see the event that it was changed, but how do you know what the VM config was a week ago, 6 months ago, or a year ago? And how do you log that? So what I did is, over the course of these 4 blog posts, is gave the community absolutely free. All you got to do is go and download SQL Server, for example, SQL Express, download the example scripts in these 4 blog posts, and it's going to show you how to do this end to end. So I want to give you a demo of that now, because it's definitely one of my favorite things to show. So when you download the scripts, let me just get rid of some of my rubric examples here. So you've got a few. So you've actually got 4 scripts that you can download from the blog. So the first one is create, very simple, that you've got to create the database first in which you're going to insert the data. So here I've got all the variables hard-coded. If you want to encrypt them and store them securely, you can, but I'm just keeping them plain text, just to keep things simple for your first run. So I'm going to connect to my local SQL Express instance, and I'm going to create a vSphere change control v1 2018 database. And handily here, if you scroll down, first of all, say there's nothing else to change. I'm always writing these scripts to be readable so you can consume it and take it as your own. And I'm basically showing you every single table that I'm going to create, all the fields, and here you can see the invoke SQL command, and it just runs through all the different tables. So it's going to automatically create the database structure that we need to create this change control database. And also handily at the start here, you can see it's first going to check to see if you've got the SQL Server module in PowerShell. If you haven't, then it's first of all going to trust the PS gallery in case you haven't already, and then it's going to download the SQL Server module from the PS gallery, import it, and then it's going to swing through. So I've already created one here just for demo purposes, but this is just V1. It's not the 2018 that I'm about to create here. So we just click run, and there you go, done. This SQL Server module in PowerShell is lightning. Let me just do a quick refresh. There you go. We've got our V1 database ready to rock. All I had to do is install SQL, configure the variables, and click go. And here we can see we've got a nice table structure of handily VMs, NICs, disks, usage, port groups, hosts, data stores, data centers, and clusters. But the examples I'm giving you, if you want to expand on this and take other objects, you can, but that was just high level what I think you might want to record. So that's the create script. Not interacting with the vCenter whatsoever. There's no need at this point. The next script is insert. So at this point, we are going to talk to the vCenter, and here we're just going to have the username, password, and we're going to talk to the SQL Server because we're going to insert all of these records in the database. And this time, we're doing a check for PowerCLI via the PowerShell gallery, and we're also doing a check for the SQL module, and then we're just going to run through, and very simply, we're just going to get a list of VMs, and we're going to select every object within it. And then for each VM in the list, you can scroll down here. What are we building? We're just building a SQL insert. And here, then invoke SQL command, and we're inserting all of that data into the tables for each VM, for each disk, you name it. As you scroll down, it's just going to log through all these different options. So that takes around 2 minutes to run in my environment. As that's running through, what I want to show you is the output. So let's go to my existing database and some tables. And let's expand, for example, VMs. So here you can see I've got all the different the columns in my VM table, and you can see the last updated, and it's basically logging each VM, its identifier, the power state, guest info, CPUs, cores, memory, the host that it's on, the folder, you name it. If it's in Power CLI, I've logged it in this database here. We can see the version, used space, provision space, data stores that it's using, all the way over, all this useful information. And every time you run this insert script, it's just going to create a new row for each object. So you can do this every hour, every day, every week, and you can do this indefinitely. It's completely up to you. If we look, for example, at hosts, we want to see what our host configuration was in the last time we ran this. Here you can see each host, where it's connected, yada, yada. So you can use this for multiple different things. For me, I think the bugbear of my life when I was a VMware admin was change control, and the fact that you had to jump through the hoops. And I think I'd personally use this as my defense mechanism, and that, hey, I didn't change anything. Look, you can see the log that it never changed, so it's nothing to do with me. But and it's also good for your own fact finding if you want to see, hey, what was the previous config, or how much storage space was this VM using, for example, 6 months ago. Because if you go into the VM disk usage, this is the same as vPartition info that you would get from the different reporting tools that you can use, where, look here, you can see each disk capacity, the free space in gigabyte, megabyte. We can see the disk path, so I'm also reporting on the drive letter here. So same info that you get from RV tools, but we're just putting it and logging it in a SQL database. So that's the data in the database, and here's some pretty cool examples. So there's a query script showing you, right, for example, if you want to see a nice output of the most recent data available, showing total VM size provisioned and used. It's kind of handy for sizing and backup of points, hint, hint, nudge, nudge. But then maybe we want to take the most recent and the oldest data and then calculate the growth over a certain period. That's also useful. Or maybe we want to see all configurations for a certain VM disk over the period of its life. When was it resized, for example? You can use this to figure out when it was. Or maybe here we want to see every single VM NIC configuration for a VM. What was its IP address reporting as a month ago versus today? On and on. Honestly, the limit to your imagination. This is just the examples that I can come up with. And then the last script is prune. Because one thing you might want to do is keep this data forever. So all you simply have to do here is specify a SQL max retention day history in days. So if you only want to keep, I don't know, 30 days, 90, 365, just change the figure here, and then anything beyond this date, it's going to simply prune it out of the database if you want to stop it growing so big. I'll be honest, it's not huge anyway. I've done my best to split out and optimize the table structure. It's not huge, but I just wanted to cover it off because I realized that if I was consuming this, it'd be the last thing that I asked for. And we can see that script is now run. Let's go back to our database here. Let's expand it out. Let's do select top 1000 VMs. And the beauty of a live demo. There you go. Oh, I promise I ran it 3 times before. So that's absolutely empty. That's brilliant. I love it. But you can tweak it. You can play with it. You can figure it out. It's all pretty self-explanatory. And if I go back, just show you the example. So all you got to Google is virtually sober, and then vSphere Change Management DB, and you'll get these steps here, and copy and paste and run with it. And I promise I'll come back and I'll figure out why that one didn't work. So that's my cool little demo. That's one of the things. If you want a detailed list of all the different parts and the cost of each one for the Hyperconverged Homelab 2.0, I will be putting it on a blog post soon. So I'll tweet that out on virtuallysober.com. And this was early access. This is before I've even finished writing the blog post. So I hope you guys enjoyed it, and I'll take any other questions if we got them.
I really think everybody enjoyed it, but we're also the comment section has been going crazy on your change management, and everybody's like, oh my god, this is like a full product. It's like, yeah, it's free. Just go check out the blog post. It's really cool.
Yeah, it's something I definitely could have done within my time when I had my own infrastructure, but now it's also pretty cool. Let's look here.
All right, guys. Anybody else have any questions?
I know why. Hang on. The script did work. It's my own stupidity. So I've got to fix this. So let me just show you exactly what happened. Hang on.
That's like 90% of all of my problems that I ever have is it works.
So if you look,
it wouldn't be vBrownBag if the demo didn't go with some kind of problem.
The demo did work, I promise. This is the problem. Look, I did the insert script, and if you look at my SQL database, vSphere change control v1, and I created v1 2018. So all I did is I added the rows into the wrong database. So it did work. User error, but there you go.
It did exactly what you told it to.
Exactly.
Get this one. I never heard this one before. Picnic. Problem in chair, not in computer. Thank you, Stephen Godcaster. That's amazing.
So that's it. That's all I got for you guys.
All right, guys. Any questions you want to send over? I can open the microphone if you want as well.
If anybody wants to just raise your hand in the GoToWebinar, and we'll get you open.
Well, you're getting a lot of kudos. Valdez here from Brazil is sending fantastic. I loved it. Thanks for sharing. Pretty dang impressive lab. What you know, one thing you did not mention. Did you ever stop and think how much you really did spend on the whole thing?
You know what? Yes, and I have to go back to it. When I could only power on 50 VMs, I cracked open a very strong drink, and I thought, I can't believe I just spent that much money for 50 VMs. My life's over. And I thought, hang on, don't give up. Go back to what you know, and everything turned out okay. And now, I'll be honest, because I use it every day to do my job, it's worth every dollar.
It happened to me. I just started working for VMware maybe 9 months ago, and going from a customer that had all these servers, loads of servers, to having nothing, it just freaked me out. So I had to buy my own good home lab. So I totally know what you're saying. Someone is saying that remember that if it's for professional purposes, you can put it off in your taxes. So
that's a timely reminder considering what season we're coming up to. So thank you for that. And the other thing I'd say is, I think the one thing we can all agree on for most vendors out there, that if you're accessing a shared lab with multiple other people on there, it's never pretty. So having your own resource that only you can break is also pretty handy as well.
And also having to manage the full installation yourself and the upgrades yourself. That's when normally the little details come around.
Yeah, definitely.
There was a comment that this form factor of your case and everything in it would be awesome for emergency DR. You could toss it in the back of a truck and drop it off somewhere, and you've got a small little DR lab. So
hey,
I was thinking,
someone wants to write me a check, they can borrow it for sure. No problem.
DR as a service. Otherwise, HomeLab as a service. If you get this thing solid, you could probably get some people that would be interested in just buying this form factor, and you got HomeLab as a service.
We are getting asked for the WAF, wife acceptance factor. I don't know if you're married at all.
I am married, so that's one. I've never heard that acronym him. That's fantastic. And two, I justified it for work purposes. I said, I need this to do my job. I promise I'll earn it back in doing such a fantastic job as a sales engineer. And it was, it definitely wasn't a one hit and got what I wanted. I had to build a successful campaign over multiple months where I just broached the subject of a new lab one week, and then a couple weeks later, I'm like, hey, looking into it and thinking about this. So, as you know, over the course of 3-4 months, when I finally pulled the trigger, yes, it wasn't totally accepted, but I'd done my best to minimize the impact.
Love it, love it. Happy wife, happy life. Yep. All right. I think we can wrap this one up. Thank you, Josh, and thank you everybody who attended. Talking Home Labs is such a geek out. We just enjoy it. So thank you so much for sharing your journey with us.
Thanks for having me.
And I'll stop the recording now.